In this video, we're going to focus on parallelograms and their properties, and then we'll use their properties to help us solve for some unknown measures. So first, let's talk about the properties of a parallelogram. If you're using those fill-in notes, I gave you some guides to help you draw a parallelogram, and then you can use a protractor to verify each of these properties. So the first property is that opposite sides are parallel. Opposite sides are across from each other. Symbol for parallel in writing looks like that. But when we draw parallel lines in a diagram, we use arrows to symbolize their parallel. And they get the same amount of arrows if they're parallel to each other. So opposite sides are parallel. Because we have parallel lines being intersected by another line, we can think about all of those parallel line angle types and properties that we talked about a while ago when we introduced parallel lines. So all of those angle types are now part of our quadrilateral, and more specifically, they're part of the parallelogram. Opposite sides are congruent. So sides that are across from each other are the same exact length. You can use your ruler on your protractor to verify that. The symbol for congruent lengths or segments is a little hash mark. They have the same number of hash marks. They're congruent to each other. The third property is that opposite angles are congruent. And when we talk about opposite angles, they're diagonally across from each other. These two angles are called consecutive angles. That's the fourth property. Consecutive angles and same side angles are the same thing, and they're going to be supplementary. They're going to add up to 180. So when we talk about congruent angles, they have the same amount of arcs. Some people put hash marks in those arcs, and that's okay to do. So if they have the same number of arcs or the same number of hash marks on an arc, they are congruent to each other. Same side angles are supplementary. Same side angles are the same as consecutive angles. So either the angles that are on the left side add up to 180, angles that are on top add up to 180, the two angles on the right side add up to 180, and the two angles on the bottom add up to 180. And if a diagram includes the diagonal, then all of a sudden you've cut those two angles into possibly four different angles. Or if you've only drawn one diagonal, then you've broken it up into three different angles. Doesn't matter. All of those angles on the same side are going to add up to 180. And the last property talks about the diagonals. So if we draw our two diagonals, they're going to cut each other in half, and those two halves are going to be equal, but the diagonals are not going to be equal to each other. So this half of this diagonal is congruent to this half of the same diagonal. Not the same as this diagonal, but its halves are the same. So we have four different segment lengths in this diagram, and they each get the same pairing or same set of hash marks. So there's your five properties. It's a little tricky at first to remember all five of these properties, so use some study techniques, some memorization methods, whatever works for you. Make sure you know these five properties so we can do the following. Use the properties to find unknown measures. So in this first example, we can solve for y fairly easily. These are opposite angles, so they must be congruent, so y must be 65. To find z, we could think about same side angles or consecutive angles being supplementary. So 65 plus what adds up to 180, or 180 minus 65 gives us z's measurement, 115. To solve for x, there's actually three different ways we could think about it. The first way is we could think, well, if y is 65, then these two angles are alternate interior angles. They're actually the same angle. They're going to be congruent, so x must be 65. We could also look and compare these two angles, thinking back to the parallel types or angles in parallel line types. These are exactly the same angle. They're just in a different spot. Those are called corresponding angles. So they must be the same. In another method, we could use 2 steps. So if I know that this is 65, this angle inside the parallelogram is its supplement, so that's 115. And then these 2 angles are a linear pair. They're going to add up to 180. So if I do 180 minus 115, I get back to 65 right here. So sometimes there's multiple ways to figure out these unknown measures. As long as you're showing your work mathematically or providing reasons based on those properties, then make sure you give me a reason for your answer. All right, in example number 2, solving for x is just using that property that opposite angles are the same or congruent, so x must be 56. To solve for z, if we identify those 2 angles right there as alternate interior angles based on these top and bottom parallel lines, then z must be the same as 85. And then to solve for y, we can think about how all of the angles on top of this parallelogram have to add up to 180. So 56 plus 85 combine and then subtract that from 180. Or you could do 180 minus 56 minus 85, and you're left with your y measurement, 39 degrees. On to example 3. To solve for a, use the property that opposite sides are congruent. So 3a must equal 6. 3 times what is 6? Well, a must be 2. To solve for b, same property, opposite sides are congruent, but this time we're solving a quadratic. So we square root both sides to solve, and we get 2 possible solutions, positive and negative 3. It's always a good idea to check your answers and make sure it's realistic. If I plug positive 3 in here and square it, I get a positive measurement of 9. But I can also get a positive measurement of 9 if I plug in negative 3. This is not just b, it's b squared. So we do, in fact, have 2 solutions, positive and negative 3. To solve for x, we're going to use the property that opposite angles are congruent. So 5x must be equal to 75. We can divide by 5 and find that x is 15. And then to solve for y, same side angles or consecutive angles are going to add up to 180. So all of the angles on top are going to add up to 180. So 180 minus 75 minus 45 gives us our leftover measurement right there for y, which is 60. One more practice example. To solve for a, opposite sides are equal, so 5a equals 30. Solving for a, we get 6. To solve for b, again, opposite sides are equal, but this is going to take a few steps to solve. So if I set b squared minus 20 equal to 9b plus 2, I'm trying to solve a quadratic equation. In order to solve it, we need to make sure it's in standard form, or in other words, put all of our terms on the left side of the equation so that we can set the right side equal to 0, and then make sure it's in standard form, or order of exponents. So we should have b squared minus 9b minus 22. We can solve that quadratic by factoring using our x factor method because a is 1. So finding factors of negative 22 that add up to negative 9. Those factors are negative 11 and positive 2. The solutions are the opposites of those factors, or the zeros of those factor pairs. You could set those factor pairs equal to 0 to solve, or just ask yourself what's the opposite of the factors, and those are your solutions. One more time, we're going to verify that a negative solution works. If we plug it in, negative 2 squared is 4, and 4 minus 20 is a negative value, so negative 2 actually doesn't work. I should erase that. Positive 11 is our only solution there. To solve for x, each half of the diagonal is congruent to itself. So 2x minus 4 is equal to 18. We could solve that and get 11. And then to solve for y, it's the same property. 2y equals 20. And when we solve it, we get 10. So there's properties of parallelograms.